Alright, we are starting our last chapter today. This is chapter 12. We're going to just do some bits and pieces of it. So these are all about different relationships in circles. So the first word we're looking at today is what's called tangent. A tangent is a line that just touches the circle. So if you look at this line here, it only touches the circle specifically at one point. So that is your tangent line. And then the point that it hits, this point right here, we call that the point of tangency. Just to get those terms out of the way. So there's two big properties we're going to look at today. The first one says that a tangent line is blank to the radius at the point of tangency. So if you look at the picture, that's saying if we have a tangent line that meets up with a radius, it's asking for the relationship between those two, and the relationship, if you look here, is that they actually make a right angle. So we're going to fill in that a tangent line is always going to be perpendicular to the radius at the point of tangency. So that's going to be important today. We're going to be able to add right angles when we see a radius and a tangent line coming together. And then the other relationship has to do if you take a common point outside of the circle and you draw in the two tangent lines. It's recognizing the relationship of those two lines. So we're looking at this line and this line. And what happens is that those actually end up being congruent. I call these ice cream cone problems because it kind of looks like an ice cream cone. It's sideways right now. But whenever you have an ice cream cone, the two sides of your ice cream cone are equal. So you need to remember that those two pieces on the outside, because they're coming from the same point, those two tangent lines are always equal. So looking at number 1, the first thing we want to do here is figure out what angle x is. So before we can find angle x, it's recognizing what the other angles in this shape are. So if you look, we have a tangent line here and we have a tangent line here, and they're meeting up with a radius. So we know that we can put right angles in there. So that's your first step, is anytime you see a radius and a tangent line coming together, you can put in that those are 90 degrees. And then it's recognizing that this shape then is a quadrilateral. And quadrilaterals should always equal, that's right, 360. So then to find the missing angle, we have to do 90 plus 90 plus 60, which is 240, and then we're going to do 360 minus 240, which tells me that x is 120. And then for number 2, there's again a tangent line meeting with, this time this is a diameter, but it's the same relationship as a radius, is that those are going to have a right angle. So now this shape is a triangle, and we know that triangles have to equal 180 degrees. So we're going to do 55 plus 90, those are the two we know, 145. And we'll subtract from 180 this time, and that tells me the missing angle is 35 degrees, so x is 35 degrees. Okay? Alright, next type of problem. It says, is the line tangent? So they want to know if that outside line that only appears to touch the circle, if it really is a tangent line. So we can't just say, I'm looking at it and it looks like it only touches the circle once, it must be a tangent line. There needs to be geometric proof. There needs to be a reason that that's the case. So it's looking at the fact that that is again joining up with a radius. So if that were really a tangent line, then there should be a right angle here. So that's really what we're testing for. We want to know, is that a right angle? So to test that, we really want to know if that's a right triangle. And in order for that to be a right triangle, that would have to mean that a squared plus b squared equals c squared. They have to be equal for it to be a right triangle, so that's what we're going to use to test this. When you're using that, make sure that you're using the full sides of each triangle. This particular problem, we know each of the full sides. So one full side is 2.5, one full side is 6, and the hypotenuse, the biggest side, is 6.2 or 6.5 squared. Please make sure you're putting that biggest side in for c squared. So now we're just gonna see if this works out. We get 6.25 plus 36 has to equal 42.25. And then if I add here, I get 42.25 equal to 42.25. So the fact that that is equal to each other tells me that this is going to be a right triangle, which means that it is a tangent line. So the answer here is yes. Alright, so looking at number 4, again, I'm looking where the tangent and the radius come together. That's how I know where to put the right angle. So the right angle is going to go there. And then I need to test and see if a squared plus b squared is equal to c squared. But make sure whatever you're doing, whatever you're plugging in is a whole side. 9 is a full side, 12 is a full side. But we did not know what this full side is. We need to fill that in. The key to filling that in is filling in this other little part here and recognizing what that is right now. That's a radius. So I can fill in that missing piece with the fact that it has to be the same length as the other radius. So this is going to be 9. So that whole side is 17. That's what I'm going to plug into the formula here. Just make sure whatever you're using does measure the full side of the triangle. And then we're going to see if this works out. This is 81 plus 144 equals 289. We get 225 equals 289. That is not equal, so the answer for this one is no, this is not a tangent line. Alright, the next set of problems are similar. We again have a line that appears to be tangent. We're going to assume that's a tangent line, and it's joining the radius. So we're again going to go and put the right angle in, but this time they're trying to tell us to find x. So we're still going to do a squared plus b squared equals c squared, but now we're going to have a variable to solve for. Please be careful when you're plugging in, just like I said on the last page. You need to use the whole side. One whole side 7, one other whole side is x. But that 18 is not measuring the whole side. We need to figure out what that whole side is. So again, it's filling in that this missing piece is a radius, and that's a radius. So that's going to be 7. And then that 7 plus 18 gives me that whole side's 25. So this is going to be 25 squared. And then we're just going to work out Pythagorean theorem here. We get 49 plus x squared equals 625. Subtract the 49. X squared is equal to 576. And take the square root of that. We get that x is equal to 24. Okay? Number 6, I'm looking at the line that appears to be tangent here. That one's tangent. And then this is the diameter that meets up with it. Those are going to make a right angle. So now that I have the right angle, that's going to allow me to fill in a squared plus b squared equals c squared. One side is x squared. But be careful with this red side. You need to know what the whole diameter is, what the whole side of that triangle is. This would be 7.2. So this is going to be 14.4. So it's going to be plus 14.4 squared equal to the last big side is 19.4 squared. So it's going to be x squared plus, that turns out to be 207.36, and 19.4 squared is 376.36. And then we're going to subtract. And we get x squared is equal to 169, and take the square root, and x is equal to 13. Okay, so again, the key with these is recognizing that they're forming right triangles, and because it's a right triangle, we can use Pythagorean theorem. Alright, this last type of problem actually uses the other property that says if we find a point outside the circle, like this point here, and there are two tangent lines drawn, that those are going to be equal, because look at that section as being an ice cream cone, and if one side's 4 centimeters and the other side's 4 centimeters. So our goal here is to find the whole perimeter, so we're going to find each little section and fill in, and then we'll go back and figure out what the big section is. So here's another piece of the ice cream cone here, so those are on the same ice cream cone. This is going to be 5 centimeters. And then we do the other thing with the other little part down here, is this guy and this guy are going to each be 2 centimeters. So what that then helps me with is we had that one last missing section up here, is I can subtract 8 minus 2, and that tells me that this section has to be 6 centimeters, which means this guy over here is 6 centimeters. So then I'm just going to fill in all the big pieces. This big side then is 6, this big side is 9, and this big side is 11. So to find the perimeter, we're just adding up all those big numbers. So it's going to be 8 plus 6 plus 9 plus 11, and that's going to come out to 24 centimeters. Alright, this next one actually has a typo. So if you guys could fix that, that's supposed to say inches there. It's not supposed to say centimeters. So pretend like this is inches. They're supposed to say all the same things. So for this one, if we want to find the perimeter, we're actually only missing one piece. We're missing what this whole section is, but in order to get that whole section, we have to actually go around the whole shape right now to get there, because we need that other top section of that piece. And in order to get that, we actually have to go this way and walk around the whole problem. So we call these walk around problems in geometry, because we have to go the whole direction all the way around to get to it. So I'm going to fill in that this is 9 centimeters, or 9 inches, sorry. And then I can find that this missing piece, to get to 19, that would have to be 10 inches. And then this is part of the same ice cream cone, so that has to be 10 inches as well. And then this top section, to get to 24, this would have to be 14 inches. Which means this, because it's on the same ice cream cone, has to be 14 inches. So then the whole section here ends up being 23 inches. And then to find the perimeter, we just add the big numbers, 23 plus 19 plus 24, and we get 66 inches. Okay? You guys have a couple problems to try on Class Kick, and then you have a short homework assignment to try as well.